After it has been sent into space beyond 650 humans over more than half a century and in every possible condition, we have begun to notice two or three things that apparently are always fundamental to keeping humans alive and operational, even on the longest and most difficult missions we send them on now. One of the most important things we have noticed is that they regularly eat multiple times a day. If you thought, oh my God, how do we do that when we send them to the moon for months? Well, it's indeed a problem because if we bring food from here, it costs us a lot in terms of rockets to launch, costs for the entire mission to keep that food for months, etc. But if we can start growing it on the spot, this could help us keep humans alive much longer and in much more challenging destinations. So the publication I'm telling you about today is precisely about this, how to try to cultivate on lunar soil, to be precise, since our next big step as humans will be to build a permanent outpost at the south pole of the moon. And in particular, I want to tell you about chickpeas. Stressed chickpeas, which I think is one of the most incredible things I've been able to say this year in terms of scientific discoveries. I never thought I could be impatient with chickpeas, but here we are talking about stressed chickpeas. And these are some of the chickpeas grown in lunar soil, 75% to be exact. It's not soil brought directly from the moon because unfortunately we have too little of that. But it's simulated soil to be more or less equal to the regolith we see on the moon. What we see on the moon is called regolith, which is very different from the soil we are accustomed to because it has no nutrient properties. So, as you can imagine, on the moon, in the absence of life, there isn't much that can enrich lunar soil with organic material. In fact, this is a big problem if we want to cultivate using the soil directly, or the regolith we find there. Regolith is mainly composed of lunar rocks broken into pieces over billions of years by continuous impacts from small and large asteroids and then also altered by radiation impact, both cosmic rays and solar radiation. Now, during the mission, we've recovered a lot of material from the moon, both regolith in the form of fine dust and larger rocks. We found that they're made up of small crystals that are oxides of various types of metals. They are often glassy, and it's not the ideal environment for plants to grow or for anything living, in fact. It's a problem even for the astronauts themselves if they end up breathing this regolith afterward, in small doses, of course. So for astronauts who went to the moon for 2 or 3 days, it wasn't a huge problem. But if we're talking about astronauts who have to stay there for months, it could really become a problem. So while on one hand we're working hard on how to avoid lunar dust, the regolith, from the suits and how to prevent it from being breathed by astronauts who will be there, on the other hand, for example, we're thinking in this project about how we can use regolith to our advantage, because it could become a basis for soil. But how do we do it? Well, the trick is to use techniques we also have here on Earth. So at least the trick proposed by the scientists I'm talking about today is to try to fertilize this soil with recovery techniques that we are used to using on Earth. One of these concerns fungi and the other concerns worms. So, fungi and worms could be our best companions for the long-term adventures on the moon and Mars. In this case, these are two systems used to enrich soils on Earth that are extremely poor and therefore to improve them to be able to cultivate again. In the case of worms, which we'll talk about shortly, they are composting worms. And in the case of fungi, it's something called AMF, which stands for arbuscular mycorrhizal fungi. Anyway, the basic idea of the publication is to use fungi to capture toxins from lunar soil inside the soil and then within the roots and in the fungi themselves, thus avoiding many of these toxins ending up in the plant and even in what we eat, like astronauts. So these have been studied extensively on Earth. They are absolutely well-known and very proven things in many conditions. So they become an excellent basis to work from here on how to customize them for lunar soil. The problem with lunar soil, as I said, is the lack of nutrients, but also the lack of microorganisms that can help the plant grow for many fundamental processes. And the toxins we talked about, in addition to low gravity and also to lack of water. Now we can recover water from the lunar South Pole, as we said. Or I don't know if I've told you in this video anyway. In short, we found vast deposits of water at the South Pole of the moon that we can use, but for the rest we should be able to manage. Now what you see here are microscope photos of fungi of this type that bind around the roots and can work together with the plant. This doesn't kill the plant, it actually enriches the plant and helps it grow better, thus enriching the soil. Now the other thing we can do is compare them with other solutions. So in this case, this graph comes directly from the study. They have cultivated both plants in unaltered soil and plants in altered soil, as well as plants in altered soil, in this way but with various percentages. They use 75% lunar regolith as the base, as you can see here, and then they notice that this allows plants to grow even though they take a little longer, about 120 days instead of 100 days. What plants did we use? We used, as I said, cute little chickpea plants that managed to grow anyway. The two researchers are Jessica Atkin and Sarah Oliveira Santos, who come from Texas University to Brown University, and they did a splendid job. This is one of the best publications I've read so far, by the way, also with a wonderful title, which is From Dust to Seed, a Lunar Chick Pea Story. Many hearts, it's beautiful. And in this publication, you can find the story of how they did it using these two techniques of fungi and worms to enrich lunar soil, and studies on how roots grew in soil without this and with various dosages. What they noticed is that the chickpeas grow, they manage, but they grow much more stressed during their life. This means that at the moment, we don't have a strategy that can work 100%. They grow slower, they grow stressed, but this is a good basis. If we had seen that they don't grow, don't bear fruit, and die even with a lot of help from plants and fungi and worms, it would have been a major problem. But noticing that actually they can manage, this means we have good chances to work on it. Among other things, they were Californian red worms that helped a lot with soil enrichment, and these can be fundamental also for another thing that I think is one of the most obvious things when you think about it, but that we at least hadn't thought much about on the International Space Station when we no longer need, for example, clothes used for a long time by astronauts or other types of cotton material we use for cleaning, etc. Many of those things we simply burn, so space underwear isn't washed, it's burned in the atmosphere. Not burned with a flamethrower or anything, it's simply put in shuttles that already burn in the atmosphere by themselves. And so, here we leave behind what we don't need. But on the moon, we could use worms of this type to create compost because anyway, if we use cotton clothes, that's organic matter. And so from dirty clothes to all the material that can be recycled, if we already bring material from Earth that can become compost at the end of its life, this gives us a lot of ways to recover many resources, and not only that, but this soil can be the basis because life, as they say in Jurassic Park, always finds a way. Imagine in the future a lunar base where a part is isolated and destined for the greenhouse and that part is pressurized. So with the atmosphere, then the plants and life can work over the years in all that soil. All that soil becomes the basis for another generation of bacteria and microorganisms and fungi, and then another generation and another generation within decades. We can have a lot of soil on the moon, and not only that, we can find combinations of mutations of plant varieties that can work better not only to grow in lunar soil, but also to facilitate this work of compost creation and improvement of lunar soil. This doesn't mean we have to make the entire moon habitable, but maybe we start with experiments with a small dome now. Obviously, this works with a part of the sunlight, so when you see in the illustration something like this, remember that without an atmosphere, if you expose living organisms only through glass, they receive high doses of all kinds of ultraviolet radiation. So no, this would be screened, obviously, so you can only let through the part of the light that is useful for plants. And on the moon, there are 2 weeks of light and 2 weeks of darkness. So during the 2 weeks of darkness, you have to have artificial light, but you could imagine, for example, a system with glasses that change to let through how much light is needed and then have LEDs that serve to increase the light to simulate a light cycle similar to what we have on Earth for plants. Moreover, the fundamental thing to have such greenhouses is not only the fact of being able to eat, because the other important thing for humans besides being able to eat is psychological. Having a greenhouse where humans can take care of plants, cultivate them, live, and be among plants is incredibly important, at least from the studies done so far. So if we really want to have humans living long-term in other distant places, we have to bring not only humans, but also life. And I think this is one of the most beautiful lessons we have ever learned about ourselves and about our humanity. The fact that humanity is not disconnected from the environment in which we live. And I think this is precisely the favorite lesson for me of space exploration. With humans, wherever we go, we have to bring part of our biosphere. And so, this is a beautiful attempt to start working around this, and the fact that we can start thinking about what kind of diet to give astronauts is beautiful. So I hope you like chickpeas, if you want to be lunar astronauts. And with this, I remind you that the publication is wonderful. It's full of things I didn't have time to tell you here, but I recommend reading it. It's called From Dust to Seed, a lunar chickpea story. Here we are at the end. A few more little curiosities for those of you who remember the Martian when he grew potatoes on Mars. We did that too as a test. We really tried to grow potatoes in simulated soil similar to that of Mars, and it works. It grows poorly, and with different things you have to do, for example, in Martian soil, we found perchlorates that are not particularly positive for life, so you have to wash them first, but it can be done. But beyond that, one of the most important things seen in that movie is the use of human feces to fertilize the soil. Now, it's not that we can't use them, but if we really want to use our feces to fertilize better, or to fertilize the soil, we have to treat them. And so, we can't just send them into the soil like that, but they can be a good basis. So if we start finding ways to remove harmful bacteria and toxins, what remains is still organic matter. And in a place where there's nothing, every single gram of organic matter can be absolutely fundamental.